Hello everyone, welcome to today's lecture. In this lecture, we are going to start with our first chapter, which is a computer data representation. So let's start. So in this chapter, mainly two parts we are learning, which is a computer data representations and register, transfer and micro operations. In the computer data representations, we are going to learn about basic computer data types, representations of numbers like fixed point numbers and floating point numbers, and how we can represent numbers in the sense of computer. Next is a register, transfer and micro operations. So in that we are going to learn about register transfer language, and then we are moved to the register transfer, then bus and memory transfer, arithmetic micro operations, logical micro operations, shift operations and arithmetic logic shift units. So these are the content that we are going to learn in this chapter. So let's start with the first, which is a computer data representation. So here data representation, so it is made up with these two words, which is data and representation. So let's understand what is data. So data refers to the symbols that represent people, event, things and ideas. Data can be a name, a number, a colors in photographs, or the notes in musical composition. Anything that represents something, that is called data. So suppose for example, I will show you one number, that is 7852. So that is a data. Yes, it can be a pin code number, it can be a flat number, it can be a house number, or it can be a street number, anything. So that is called a data. Now data representation refers to the form in which data is stored, processed and transmitted. So we have a data, and when we store the data, or we can process the data, or we are transmitting the data, so that form of data, that is called data representation. So devices such as smartphones, iPods and computers store data in digital formats that can be handled by electronic circuits. So now we all are familiar with the digital devices. Suppose we capture one picture in our phone, that is stored in our phone. So that picture is also stored in one format in the memory. Same as suppose we are storing our text file in our computer. So that is also stored in some another form in our computer's memory. So digitization is the process of converting information such as text, numbers, photo or music into a digital data that can be manipulated by electronic devices. So as I said that we have lots of information, we have lots of data, but storing the data into the memory is a different thing. Suppose we are listening to music, but how it can be stored in the computer? Yes, so it needs to convert that data into some another formats that can supported by our electronic gadgets. So that is called the digitization process. Now as I said, that data is stored in the computer or any devices that are not in the same format that we have captured, but the format of the data is different. So suppose in this image you can see that suppose we are storing our data into disk drives. So disk drive stores data as a magnetized particles. So suppose this is a disk drive to store the data. So in that disk drive, data is stored as magnetized particle. Magnetized particle has two positive and negative particles. So the data is stored in that format. Suppose we are storing the data on the CDs or DVDs. So on that data is stored in the form of dark and light spots as shown in this figure. Suppose we are storing data on the circuit boards. So circuit boards carries the data as a pulses or the currents. And suppose we are storing our data onto the computer or any digital devices. So at that time data is stored on the form of ASCII codes, and that represents data as zeros and ones. Now we already know that we are learning this subject, computer organization and architecture, just to know that how data is stored, how computer processes the data. Yes, so in the computer system, our data is stored in the form of zeros and 1 bits. So here the zeros and 1 used to represent digital data are referred to as a binary digits. So now you all are clear that our data is stored in the form of zeros and ones in our computer's memory, and it is called the binary format. Now anyone asks to you that how our data is stored in the computer, so now you can easily answer that the data is stored in the binary format. A bits is 0 and 1 used in the digital representation of data. A digital file usually referred to simply as a file and is a named collection of data that exists on storage medium such as hard disk, CDs, DVDs or the flash drive. So it contains a digital data, so it can be stored in any storage device with the different formats. Now we already know what is a binary digits. Now the next is how we can convert the decimal numbers into the binary format, because in our further slides we are using the binary conversion of digital numbers. So that is why I will give you the overview that how we can convert the decimal numbers into the binary numbers. Suppose here the question is convert the decimal number 10 to binary number. So to convert this number, I will show you the shortest way to convert the decimal into the binary. So this is the series. It's the series is start with the 0. Yes, series is start with the 0. So at the middle, first it is a 0, then 1. So this is the fixed 2 digit. Then 1 into 2 is 2, 2 into 2 is 4, 4 into 2 is 8, 8 into 2 is 16, 16 into 2 and so on. Same is at this side 1 by 2 and then 1 by 4 and then 1 by 8 and 1 by 16 and 1 by 32. So this is one whole series. Now our question is we have to convert the 10 into the binary. Yes. So to convert 10 into the binary, let's start with the 16. Suppose 16, if we are including 16, then it is a greater than 10. So we are not including 16. Then we'll start with the 8. Yes, so 8 plus something become 10. Yes, so we'll write here 1. Then 8 plus 4 is not 10, so we'll write 0. 8 plus 2 equals to 10. Yes, then we will write here 1. And 8 plus 2 equals to 10 and 10 plus 1 equals to 11. So he'll write 0. So the binary number generated of 10 is 10, 10. So this is the simple way to convert the decimal to binary. Suppose we have to convert 0.125 into the binary. So for that we'll start with the 1 by 2. So 1 by 2 is not 0.125, we'll write 0 here. Then 1 by 4 is not 125. Then 1 by 8 is a 0.125. Yes, so we'll write here 1. So the binary number is become 0001. So this is how we can easily convert decimal to binary. So this is the overview of that. So I hope now you are clear with how we can convert the decimal to binary. Now, as I said, the first topic is computer data representation. So computer data representation basically has two types or two data types, which is a fixed point numbers and floating point numbers. Yes. So there are two basic data types implemented in the computer system, which is a fixed point numbers and the floating point numbers. Now you can compare this topic as, suppose you are learning the C language. So in the C language there are many data type used. Suppose float, integer, double. Yes. So this data type are used to store the data. Same as in the computer, if you want to store data onto the computer, there are basically two data types for that, which is a fixed point numbers and the floating point numbers. And the representations of such data types is called the fixed point representation and floating point representation. So let's start with the fixed point representation. So in integer numbers, radix point is a fixed and assumed to be the right of the rightmost digit. As a radix point is fixed, the number system is referred a fixed point number system, or we can say that, or the another definition of the fixed point number is fixed point number have a decimal in the fixed position. So as per the definition, in integer numbers, radix point means this decimal point, or we can say that the dot. So it is also called decimal or the radix point. So here radix point is a fixed and assumed to be the right of the rightmost digit. Suppose we are writing 125 here. So it is an integer number and the radix point is at the right position. A radix point is fixed and the number system is referred as a fixed point number system. Suppose 125.10. So this number is called the fixed point number because here we can simply remember that the radix point or the decimal point is fixed here. We cannot move this point at anywhere. Suppose we are writing 5.5. So this is a fixed point number because in between that the decimal point at the fixed location and that cannot be moved. So here the example in the binary is 0010.100. So that is an example of fixed point number and 1.5 is the example. So any number who has a fixed decimal or the radix point at that particular location, this is called a fixed point number. And this is a syntax that first number is the integer number, then the decimal point, and then another number is a fractional part. So here this is the integer number, decimal point, and the fractional part. So this is all about fixed point numbers. Now with the fixed point number system, we can represent positive or negative integer numbers. Suppose I want to write the positive numbers plus 1, 2, 5. Or suppose I want to write minus 120. Suppose we will write this number onto one text file. So now with the sign we can easily write this number, but suppose if you want to store this number onto the computer's memory, then how can we store that positive and negative number, or how we can differentiate this number is positive or this number is negative? So for that, if MSB is 1, then number is negative. If MSB is 0, then number is the positive. This is the two basic condition to identify that number is positive or the negative. So here suppose this is a 8-bit field and the binary number is 1 1 0 1 1 1. Yes, this is the number. Suppose here 101 10111. So this is the number. So how we can identify that the number is positive or the negative? So this bit is called the MSB. The first bit of a binary number is called the MSB. So here the condition, if MSB is 1, number is negative. Here the MSB value is 1, yes. So this number can be minus, or suppose 120. And suppose this first digit is a 0. So here if MSB is 0, the number is a positive. Suppose this number is 0. So based on the MSB bit, we can identify that number is positive or the negative. Here we can, in this figure, we can see that this is a decimal point, this is a fractional part, and this is an integer part. Yes. And now apart from this part, there is one single bit space, and this bit is called the MSB bit, and based on that we can identify that number is positive or the negative. So let's take one example to understand this clearly. So here the leftmost bit in binary number represents sign of the number. Sign magnitude format for 8-bit sign bit number is, suppose here the decimal number is 8. So for 8, the binary is, so we can easily find what is the binary number for 8. So for 8, we'll put 1 here, then 0, and then 0, and then 0. And suppose it is a 8-bit, so we'll write also 0, 0, 0 and 0. So this is the 8-bit binary format of decimal 8 number, 0001 000. So here, okay, 0001 000, and here 1 again 0. So this 0 represents that the number is positive or negative. Here the sign bit or the MSB bit is 0. It means the number is positive. Same as here the sign bit or the MSB bit is 1. That is why the number is negative. So I hope now you all are clear that when number is positive and when number is negative. So now the next is how we can represent these fixed point numbers. That is called fixed point representation. So the fixed point or the integer numbers are represented in the two forms, which is signed integers and unsigned integers. So unsigned integer numbers represent all the positive numbers. So it ranges from 0 to 255. So in the unsigned integer numbers, all the numbers are positive and no number is negative. But in the signed magnitude represent or in the signed integer, the number may contain negative or the positive numbers. So and the range of that signed integer is -127 to +127, and that can be represented in the two form, which is the ones complement and the twos complement of the number. So now you all are clear that the number is fixed point number is represented in the two form, which is unsigned integers and signed integers. In the unsigned integers, all numbers are positives and the range is 0 to 255, while in the signed integers, numbers can be positive or the negatives and the range is -127 to +127, and it can be represented in the two form, which is a ones complement and twos complement. Now let's understand what is a ones complement representation, how we can find the ones complement of the number. So the ones complement of a binary number is the number that results when we change all ones to zeros and the zeros to 1. So it is very easy to find ones complement of the number. Suppose here in the example, the binary number is 1101 0100. So to find the ones complement of this number, we only have to swap the 0 to 1 and 1 to 0. So here the first digit is 1, so we will swap to 0. Second is 1, so it is 0. Third is 0, so we'll swap it with 1. Fourth is 1, so it is 0. Then 0, then 1. Here 1, so 0. And this both are 0, so the number is 1 1. So this is the ones complement of any binary number. So you can see that this is the number 110 101 00, and the ones complement is 001 0 1 0 1 1, same as we have calculated. So this is how you can calculate the ones complement. To find the ones complement, we have to swap 1 with 0 and 0 with 1. So this is how ones complement is calculated. Second is twos complement representation. So twos complement is the binary number that results when we add 1 to the ones complement. It is given as, so the equation for the twos complement is ones complement plus 1. So here we need to do the binary addition. So suppose the binary representation of 5 is 1010, and now we'll calculate the ones complement of it. So here the step 1 is to find the ones complement. So we'll calculate the ones complement of this binary number. The ones complement becomes, because this is 0, so it is 1 1, so 0, then 1 and then 0. So this is the ones complement. Now the next step is add 1 to the ones complement. So here the ones complement is 1010, and we have to add 1 into that ones complement number. So the addition is something like 0 plus 1 equals to 1. Here 1 is as it is, 0 as it is, and 1 as it is. So here twos complement is 1011. So this is how we can represent the fixed point with the twos complement. So I hope now you all are clear with ones complement and the twos complement. So this is example that how we can calculate the decimal to binary numbers, and some of the exercise is given for you, and some of the exercise for 1's complement and 2's complements is given for you. So you can practice with these questions. Now the second data type is a floating point representation. Now we all are clear with the fixed point representation. Now the second is floating point. Floating point notation is an alternative to fixed point notation and is the representation that most modern computers use when storing the fractional numbers in the memory. So nowadays, or the modern computers use the data type for storing the data is a floating point notation. Floating point notation is a way to represent very large or very small numbers precisely using scientific notation in the binary. So the floating point representation has mainly three fields: sign, significant digits, and exponents. So here this is the syntax of floating point number. The syntax is, first is a sign, so sign can be plus or minus, then significant digit, it means the actual integer value, and then a base raised to some exponent. So this can be represented like, suppose a sign is positive, so plus, then significant number or the any integer value which is a 10 into base raised to exponent, so base raised to and 2 raised to 5. So this become one numbers, and this number is called the floating point representation of any number. Now let's understand in detail. So let us consider the binary number 111101.1000110 represented in the floating point format. To represent the above number in the floating point number, first binary point is shifted to right of the first bit and the number is multiplied by the correct scaling factor to get the same value. The number should be in the normalized form and is given as. Now let's calculate it. So the first condition is we will write this number as it is. So this is the first step. Now we have to move this decimal point at after the first digit. So here the number is become 1.111011000110. Now as per the syntax, this is called the significant digit and then scaling factor 2, because it is a binary number, so that is why the scaling factor is 2. And now exponent. Exponent is calculated like we have shifted this decimal or the radix point to 5 digits. So this is the first, second, third, fourth and fifth. So because we have shifted this decimal point to the 5 numbers, so that is why our exponent is become 5. Okay, so that is how we can normalize any number into the floating point representation. So now the question is, why floating point number representation? Yes, we have already the fixed point representation to store the data. So why it is needed? Suppose there is a one big number like 50000 up to 10 times 0. So this number is very long and it can be more than this. So to store this data, the memory requires more bits. Yes, so that is why to save the memory, for that floating point representation is very useful, because this is a decimal number, and we can write this number as 5 into 10 raised to 10. Here 10 because the number is a decimal. So this long number can be represented in this small format. So that is why the floating point representation is very useful to save the memory, because fixed point representation requires more bits in the memory. So it is important that the base in the scaling factor is fixed and 2. Why? Because it is a binary number. We are converting or normalizing binary number into the floating point representation. So that is why base is become 2. Base is also called the scaling factor. This is called the exponents, and after moving the decimal points to the first location, The remaining number is called the significant digits, or it is also called mantissa. So that is all about floating point representation. Thank you so much for watching this video.